Application of the law of cosines, bearing. Remember that the bearing of an object is measured in degrees clockwise from due north. So it's a little bit different than our usual way of measuring angles, clockwise from north. Here's our scenario. We've got an airplane starting here at point A. It travels 450 miles from A to point B, and then 320 miles from B to C, and finally 200 miles from C back to A. Our job is to figure out the three bearings for the trip. Each leg of this journey has a bearing. We want to find those. One comment right off the bat, the bearing from A to B, the bearing at point A is very, very easy. I can fill that in right now. Remember, you can draw these little axes here to help you picture the bearing. The bearing is measured from north clockwise, so we're talking about this angle right here. Well, the plane was heading due south. I can tell that that's just 180 degrees. So the bearing at point A is 180. To get the other bearings, though, I'm going to need to do some work. I don't know any other angles in this picture. Well, that's where the law of cosines comes in. Do you see that this triangle is an SSS situation? I know the lengths of all three sides. Well, then I know I can find any angle I want in the triangle, and those angles, along with a little bit of geometry, should help me determine the bearings. Let's use our standard process. We know in the SSS situation that we always start by finding the largest angle in the triangle. That's so important. We want to use law of cosines for the largest angle because it might be obtuse. And inverse cosine is great at finding obtuse angles. So let's see, who would be the largest? It looks like it would be this angle C right here. The biggest side is 450, so that means angle C must be the largest angle. Well, that means I'll be using this version of the law of cosines. Obviously, in the equation, it says gamma, but gamma is the same thing as capital C in our picture. Let's go ahead and fill in the information then. So we would have 450 squared, and then the other two sides squared. Let's see, side A would be opposite angle A, so that would be the 320, and then the 200, and then the adjustment term minus 2 times the 320 times the 200 times cosine of capital C, or you could use gamma if you wanted to. The only unknown here is capital C. That's what I want to solve for. Let's clean this up a little bit. I can move over these two terms to the left side by subtracting them. And then I can divide both sides by the coefficient there of cosine C, which is the negative 2 times 320 times 200. You could, of course, multiply that out if you wanted to and have an actual number there. And then I can cancel this out. I have cosine C equals that number. Let me go to the calculator and see what that is. Be careful. If you want to type it in as I wrote it down, you'll need a parentheses around the top and a parentheses around the bottom. Okay, so close off the top and then divided by, open a new parentheses for the denominator and close that one off. Hit enter. That's the cosine ratio. I can put a few digits on the paper, but of course I want to keep it long here in the calculator, so about negative 0.4695. We have cosine C is about negative 0.4695, and then to get C, I would just do cosine inverse. By the way, that negative ratio tells me that I am dealing with a second quadrant angle, which means it is an obtuse angle, so it's a good thing we found it using the law of cosines. Back to the calculator. Let's see, I am in degree mode, and so cosine inverse of that last answer gives me right about 118 degrees. Again, I think I'll leave this long in the calculator for now, but rounding it off is right about 118. Okay, so we've figured out that this angle here is 118 degrees. That will certainly be helpful. It's not enough for me to write down these bearings. I think I need to find another angle first. Well, with an SSS situation, we found the largest angle using the law of cosines. We certainly don't need to use the law of cosines anymore. Now we have a complete angle-side pair. We know angle C and side C, which means we can turn to the law of sines. And our strategy now is to find the smallest remaining angle. We know it's acute. You can only have one obtuse angle in a triangle, which means we won't have two possibilities. It'll be a very straightforward use of the law of sines. Well, the smallest remaining angle looks to be angle B because it's opposite the smallest side. So I'll be using this version of the law of sines. I know the gamma C pairing. I know half of the beta B pairing, so I can find that missing angle. Okay, so we have sine beta, or we're just calling that capital B in this problem, divided by side B, that would be the 200, equals sine gamma. Gamma is our capital C angle, 118. Now 118 is a rounded value. I'm going to kind of put some dots there to remind myself that's not an exact value. And then divided by 450. I'll cross multiply to obtain 450 sine B equals 200 sine 118. Divide both sides by 450 and we can head to the calculator. So I'm going to get this sine ratio, sine of capital B, and when I go to the calculator, instead of just using 118, I'll go ahead and use that whole value we have in there. 200 times sine of the last answer, that 118 number, and then divided by 450 for a sine ratio of about 0.3924. Remember, we know this angle is acute, so I don't have to worry about two different possibilities. I can go straight to inverse sine on the calculator and get my answer. Angle B would simply be the inverse sine of that 0.3924 number. So we'll hit inverse sine, and to avoid rounding, of our last answer, and I get about 23.1 degrees. And so now we know this angle as well, 23.1 degrees. I think we have enough now to write down the other two bearings. And let's take a look. Remember, what you can do is you can put one of those little axes at the spot. When the plane was at spot B and it turned to head toward spot C, so it turned to go along this pathway here, we're just trying to state the angle, the bearing that it traveled. Remember, bearing is measured from north clockwise, so we're just talking about this angle right here. Well, that's the angle we just found. It's 23.1 degrees. So the bearing from point B to point C is 23.1 degrees. Okay, what about the final bearing? When the plane was at spot C and heading back to spot A. Well, I don't need to draw any axes. I'm right here at the origin, so I can easily draw the bearing. It's from north clockwise until you hit the direction. So we're talking about that angle right there. How am I going to find that angle? Well, I can do it in pieces. I already know that from here to here is 118 degrees. We figured that out already. Do you see that from here to here is very, very easy? That's just 180, right, to get from the top of the y-axis to the bottom of the y-axis. So the only piece that I'm missing is this little piece right here. Well, here's where some geometry comes into play. Do you see that the y-axis and the distance from A to B are parallel lines? They're both vertical, actually. And this section right here cuts across them. So I have two parallel lines cut by that transversal, which means this angle and this angle are the same. They are both 23.1 degrees. Well, of course, that's all the information I need. All I need to do now is add up 180 plus the 23.1 plus the 118, and I will have my bearing. Let's see, I don't think I have to worry too much about the rounding issues, but if I want to be super precise, I can grab the exact 23, and then I can also go grab the exact 118, and I get a final answer of 321.1. And that makes sense. This angle is pretty large. I mean, it's almost all the way around, so we would expect a big number like 321. We have found the 3 bearings for each leg of the trip. One last comment, another way that we could have found that final bearing, we could have finished solving the triangle by finding this third angle. That would be very fast, right? Because we know the measure of the other 2 angles. And then from geometry, we could have seen that that angle matches this angle. Well, if I knew that angle, I could easily get the bearing by just subtracting that from 360 degrees, and we would have gotten that same 321.1. Thanks for watching.